This is a cool problem that'll help explain how a cyclotron works. We're going to be shooting a deuteron through this, and we're going to try to figure out what the total distance traveled by the time it's done going through all the different spins in this entire cyclotron. So first, we're going to try to find what the average circumference is. That'd be somewhere in the middle over here, some kind of average circumference, the radius in the middle, and we're going to multiply that by the number of revolutions, and that's how we can get the total distance traveled. So let's start with the number of revolutions. In order to find that, we're going to want to think that, okay, we got this potential voltage difference thing here, right? So when we have a voltage difference and we multiply it by a charge, we're going to get the kinetic energy, a change of kinetic energy, because it's going to be like an acceleration. So it's going to give it more kinetic energy in that small little potential difference there. And then once we figure out the change of potential energy, we can try to figure out, okay, well, what's the max KE? KE max, and divide it by the change of potential energy, because every time that it goes through there, it's the same change. So, you know, every time you do that, let's say you had like a couple hundred switches through here, well, that would give you a total KE. So we're going to try to figure out how many, number of boosts does it get. It's not really quite the same thing as the number of rotations, because it's going to get boosted twice. It's going to get boosted once here, and then it's get boosted again over here. So we're going to get 2 boosts per revolution. So once we figure out how many boosts we get, we're going to divide that by 2. That's going to give us the number of revolutions. So let's try to figure out what KE max is. And in order to do that, we're going to think, okay, KE max is 1/2 mv squared, right? And if we had the max velocity, then we could find the max KE. And the max velocity would be the final velocity when it's at the final edge of this thing just before getting shot out. At the beginning, you would have like no velocity, and at the end, it would have the max velocity. So we're going to use the max radius, R max, in order to find the max velocity. And so for the radius, R max, that's going to be equal to mv max divided by QB. This is just a given equation we're supposed to know. From there, let's also notice that we've got this B. We don't really know what B is yet, but we were given the frequency, and because of that, we can use another formula. We can use the frequency formula. We'll go and put that over here. F equals QB divided by 2 pi m. So we can sort of rearrange that for the B, say that B equals 2 pi m F over Q. Well, since I'm trying to find the KE max, and I need to get this in terms of the V max over here so I can plug some stuff in and figure out these things, let's solve this equation for V max. V max is going to be equal to R max times QB divided by M. And then we're going to want to square that. Okay, so we'll square that. We're going to have this B squared over here concept, but we can replace that with this B squared. I'm squaring everything in here. That'll give us R squared Q squared over M squared times 4 pi squared M squared F squared over Q squared. Getting rid of this thing, getting rid of this thing, leaves us with 4 pi squared R squared F squared. And that's going to be our V max. Now we can plug that in over here, giving us KE equals 1/2 M and then 4 pi squared R squared F squared. So in the end, we basically just get that KE max is 2 pi squared M R squared F squared. We've got 2 pi squared times 3.34 negative 27 times the 0.572 squared times 14.5 to the 6 squared. So we get that the KE max is equal to 4.5 e to the next 12. Now from here, We'll divide it by the potential, well, the KE change that we get every time we go through here, because that'll give us the number of boosts. We already had that plan before. So let's divide that by Q delta V. Divide that by the 1.6 negative 19 times the delta V, which is 66.2. And so we get the number of boosts is 428 boosts. We're going to divide that by 2 so that we get the number of revolutions. That would be 214 revs. That's how many times this thing spun around in full circles. So that's cool. But let's also remember that we need to find the average circumference. And then we can finally figure this out. So let's start with the R average, which should be the mv over qb. And then we're also going to realize that if we're looking for the KE average, we're going to use 1/2 mv squared average. So we can kind of plug this average in here by saying 2 KE divided by m square rooted is the V average. We'll put that in there, and we'll get the V average, or the R average, is equal to m over qb times square root of 2 KE over m. And then from here, we'll try to get rid of this b again like we did before. We know b is supposed to equal to 2 pi mf over q. So we can plug that in there. And we're basically going to get that the R average is equal to square root of 2 KE. I'm going to go ahead and get rid of this m, put it inside of the square root with a square, and then we'll get rid of the m's so that there's still an m in there, and then we're just going to divide that by qb on the bottom. But we're going to replace this b over here with the reciprocal of this. We're saying q times 2 pi mf, because we're dividing there. And with that, these things will cancel, and we should get that the R average is the square root of 2 KE, KE average m divided by 2 pi mf. And the KE average is going to be our max divided by 2, so that way we get the one that's right there in the middle. So what was our KE average? Let's see if we can find it in our calculator again. It was this one. Divide that by 2. And then now we can put that stuff in there. We can multiply this by the mass. It's going to be 3.34. 24. And multiply that by the 2. And then we can square root that. Then we'll divide this whole thing by 2 pi mf. 2 pi times 3.34 times the 14.5 to the 6th. Okay, so that's going to be our average circumference, 0.404 meters. Okay, now we can just multiply that by 2 pi, because we're going to get 2 pi r, and then we can multiply that by the number of revs that we had, which was 214, and we're almost done. Check it out, times 2 pi times 214, and bam, we get the average length, or an estimation for the length of this whole thing is about 544 meters. That's crazy.